That's the official word. Welcome to the April Calumet Revisited Forum. I am Michael Bowles of the Association for the Wolf Lake Initiative. I am co-host with Dr. Valerie Pennanen, Professor Emerita of History at Calumet College. The forum is funded in part by the Indiana Humanities and the National Endowment for the Humanities. Before we hear from tonight's speaker, are there any announcements? If not, I have two. On Tuesday, May 7th at 5 p.m., Abigail Rick, a graduate student at the University of Illinois, Champaign-Urbana, will talk about her upcoming work with a team at the Illinois Natural History Survey. It is on the project that connected Powderhorn Lake and Wolf Lake in southeast Chicago last year. She and her partners want to know how cold conditions affect adult fish movement between newly connected systems. I can't talk and knit people, so sorry about that. She also has some more questions about fish, and we'll learn about that next month. On Wednesday, May 29th at 3 p.m., there will be the third meeting of planners seeking to develop a plan for the Wolf Lake watershed. Both of these meetings will be via Zoom. At this evening's Calumet Revisited Forum, Dr. Christopher Iceman will talk about air pollution in the Calumet region. After his presentation, we will have a question and answer session. The presentation this evening is being recorded. It will be available within a week on Ollie's website. Would everyone please remain on mute? And I welcome Dr. Iceman.
Well, thank you so much, Michael, for inviting me to talk. As Michael said, my name is Chris Iceman. I'm a professor at Valparaiso University, and it's really nice to get to see you all here tonight. Usually, I make sure that everyone, my students especially, know that they can ask lots of questions, and so I always make sure I have my professor safety goggles on at all times, to encourage you to see that the power of my eyebrows, really indicates my love for good questions. So please feel free to ask your questions. I don't know if I'm going to be able to read the chat and talk at the same time, but happy to stay on here as long as you want, answering questions. And tonight, primarily, I'm going to be talking about some air pollution studies that we've been doing. I am just one small part of a really awesome team of faculty members sort of across Indiana, Michigan, called the North Lake County Environmental Partnership. And we're all kind of different specialists in different areas, with a lot of overlap too. And so my particular zone of study is in air quality. And as you may know, due to our industrialized Northwest Indiana corridor and the Chicago region, we have lots of industry and lots of industry emissions that are important to us as a community. So we just recently last year received a National Institutes of Health grant to do some studies in the region. And my part of those studies primarily has been using these little devices. I don't know if you've maybe seen them before. They're these little purple air sensors, and they're just a tiny little thing. And this one's actually empty. But on the inside is a cool little device, which I have here sort of all torn apart. But so you can kind of see what's going on. And so there's a couple little inlets here where the air comes into the sensor, and we'll talk about how that sensor works. And we've been, putting these out in the region in different places to sort of do some community monitoring of air quality. And these purple air sensors are becoming quite ubiquitous across the country and actually across the world. Lots of people are using them. And we're concerned about, as scientists, are they doing a good job? And what can we sort of trust coming out of those sensors in terms of informing our community members about their air quality and what maybe we need to do to fill in some of the gaps of our knowledge there. So I think we figured this out, that I can share my screen. So I'm going to go ahead and bring up a presentation that was given just a couple weeks ago at the American Chemical Society national meeting by my student who's been working with me on this project. And his name is Abe, and he did a great job presenting there down in, we were in New Orleans, Louisiana. So it was a great time. So anyway, first slide is just kind of, introducing people to our region and some of the industries that we have here at the Gary Steelworks. And of course, we know that our steel factories, which have been very important in our national infrastructure, have also been responsible for putting out a lot of air pollution. And so we're kind of interested in what our present day situation is there. And so we're going to kind of look at these purple air sensors, and we're going to try and understand how well they're working at looking at these air quality metrics. And this is what we found out. And I will say this so far, there's probably a lot more to know and understand here. Okay, so why do we care about these purple air sensors? And I've talked about this a little bit already. They're being deployed out in communities around our country and around the world as tools to evaluate air quality. And we're kind of interested in them scientifically. Are these doing a good job? And we would like to use some other more traditional methods of studying air quality and compare those to the purple air sensors and make sure that they're doing a good job monitoring all of the diverse array of air quality metrics and particulates. And so we're also looking into, how do these devices convert the data that they collect into those values that we see on a website. And we are also, and I talked with Michael about this at the beginning of the meeting, we do studies in other areas of environmental concerns, such as soil quality and water quality. And so maybe we can get some of the other team members to talk about that next year. Would be really cool. And then, of course, one of the other interesting components of what we do is that we are working with our community members and really trying to establish relationship, because it's not just about being a scientist and getting a number. Like, we really want to help people protect themselves. We want to help people gain knowledge and understanding about their environment so that they can live a healthier, better life. And so we don't want to just be scientists that are coming in and out. We want to be long-term members of our community, working together with our community to understand historical trends as well as current issues and help them as much as we can. So, and that was really why we formed this North Lake County Environmental Partnership. But we certainly have sensors and have done studies all over Northwest Indiana, and we're forming more collaborations seemingly by the day. So if you're not aware, air particulates tend to be bad. They're not always the best thing for you. And there's really sort of two routes of exposure that are bad for human health. One is through your lungs and your breathing tube, and the other is through your gastrointestinal tract and into your stomach. And it turns out that most of the time, our airways are pretty good at filtering out large particulates, in our nose, and we sneeze and all this kind of stuff. But sometimes that can get into our throat and get swallowed into our stomach. But those are typically larger particles. Much smaller particles, or even as small down to like atoms and molecules small, those can stay suspended in our airways and make it all the way into our deep lung. And the problem with those particles is once they get into our deep lung, our body doesn't have a good way of expunging them. And so they get stuck there. And that can cause a host of other health issues. And so we're really kind of concerned about both routes and both ends of the spectrum in terms of air quality. Do we have big particles that maybe we can sort of see? But then there's a lot of things that are small that we can't see that are also not great for us as human beings. This is sort of another little metric that you can find online. And we're starting to get into kind of the numbers zone of things. And so we'll talk about this a little bit more, what these numbers mean. But if we see on one of our reported websites, or you'll even find these on, your phones can sometimes report air quality to you. You'll see a number that has to do with an air quality index, or AQI. And if your air quality index is sort of elevated by about 22, or maybe we could just say 25, and the units on that are sort of interesting. They're very small, micrograms per meter cubed. And we can get into that more later, but that's basically a mass loading in a volume. So if we have some of those particles in a volume and we go up by this value of about 25, that's about the equivalent of smoking a cigarette per day. And so when we see some air quality indices that reach, up around 150, and I don't know if you guys remember the forest fire smoke that we had over the summertime that came down from Canada. Some of our air quality indices reached those levels. And so over a time period of 24 hours, we would have smoked multiple cigarettes essentially in terms of breathing that air. And that's not to say that I have not imbibed in a good cigar from time to time. But what we're really talking about here is our ability to make a choice about our air quality. And a lot of times our communities are burdened with bad air quality. That is not a choice that they can make. And this happens not just in our community, but in communities all around the world. In the top left of this slide, you can see Salt Lake City, which has a really interesting geographical bowl between some mountain ranges, and they get some really bad inversion air quality problems. Also on this slide, we've got China, we've got India, and then Mexico City in the bottom right, all of which experience air quality issues. So we are not in any way alone in this. Many cities across the world have lots of air quality issues. And furthermore, we're all connected. It turns out air particles, once they get up in the air, they don't really see national borders. They don't see county lines. They go where they're going to go. And so there was a study that I looked into when I first started getting into air quality, which was really interesting because it showed air particulates coming all the way from the Gobi Desert in China, traveling across the Pacific Ocean and winding up on the California coast. And so air quality is not a localized phenomenon by any metric. It's definitely something that we have to worry about as a global community. And so one of the things we're trying to do is to inform our constituents in Northwest Indiana about what their air quality is. It's been somewhat of a trend that over the time that I've lived in Northwest Indiana, and it's been since I guess about 2015, that we've actually lost some of our air sensor equipment, meaning that it's been taken down or taken out of service and sort of not replaced. And so we don't have as many measuring devices out there to measure our air quality. So we thought, well, these little purple air sensors, pretty cheap. They might be kind of a nice supplement to that. And so you too can go to map.purpleair.com and you can look it up on your phone right now, and it'll usually locate where your phone is and take you right to the map so you can see if there are any purple air sensors. Say again, Ben? Okay, I guess that was, it wasn't a question maybe. But we've got here on the screen just a few of our sensors that we've placed all around Northwest Indiana. And, locally and regionally, we can see some differences in the air quality index that they're measuring. And it's a pretty simple website. If we start to get into these higher air quality indices, the sensor will kind of show like an orange or a red or even a purple if it's really bad. And then on days when the air quality is better, they tend to be, in the greens and yellows. And so it's kind of like the stoplight type of warning system for those. And what's going on inside these little sensors so that you kind of understand how they work. There are actually two sensors, and you can see them side by side here in one of the little devices. And pulling that apart in the center picture, they actually have what is basically a little red laser pointer. And that little red laser pointer shoots a beam over a photo sensor. And as the particles are drawn into that sensor, they will scatter that laser light. And based on the amount of scattered laser light that is picked up by the photosensor, they can have a correlation then to how many particles are in the air. And so that schematic is sort of shown here down at the bottom. And that's effectively the sensor gets calibrated somewhere in the factory. They figure out, how many particles they're putting into the sensor. They figure out how much light gets scattered, and they use a conversion factor then to tell you what your air quality index is. All right. Now, that being said, you might already be anticipating some problems with that particular method of measuring air quality. And the first thing I'm going to talk about is the diversity of particles that exist when we talk about air quality index and things that we're concerned with in terms of air pollution. And the first thing that's of concern is size. And we talked about the size of our particles earlier in terms of how we get exposure mechanisms in our body. Does it go into our lungs? Does it go into our stomach? And that's going to make a pretty big difference. And so I've got a little screen here that actually shows a scanning electron micrograph of some volcano aerosols that were collected a long time ago in Alaska. And you can kind of see how the particles are all kinds of different sizes. Some of them are clumped together and they're a little bit bigger. And then there's all kinds of little dots all over the place. And there's a little measuring bar at the bottom there, and that is 100 micrometers wide, that bar. And effectively, sort of the average width of a human hair is 100 micrometers. And so all of those particles are much, much smaller than a human hair, and they're really hard to see. But we can see them with some pretty advanced tools. And that's the purple air sensors are able to sense some particles that are quite small. So that's great. But then we also have to be concerned about what is our particulate matter made of. Is it made of hydrocarbons? Is it made of lead? Is it maybe even just, these are little molecules, in fact, not particles at all? Is it carbon monoxide? Is it a nitrogen oxide? Maybe it's ozone. It could be something that's really big in terms of a particle. It could be pollen, and many of you have experienced, I'm sure, allergies, and we're probably all gearing up for that this season real soon here. And pollen can absolutely be a piece of particulate matter. So because of that large diversity of things that we care about as air quality scientists, it's really hard to have one device that measures everything. And so when we use these devices, we kind of have to know something about where their happy place is, what their good zone is for working. And on top of that, it's a new technology. I mean, the technology, I guess, isn't new, but it's a new device. And so we don't know how good and how reproducible those numbers are. And so we've been digging into the literature, my students and I, looking at different studies that folks have done using these air sensors compared to their expensive equipment. And we found one paper here on the left that did a nice study where they found a conversion factor that seemed quite reliable for the sensor. And then on the right, there was another paper that did a study with relative humidity. So you might think that on a day when it's misty or rainy or foggy, those particles might get coated in water molecules, and that could very much change their behavior. And we indeed see this actually with our sensors as well. And so both of those papers helped us to come up with sort of an analytical scheme to turn the purple air numbers into something that was maybe a little bit more reliable in terms of some more advanced instrumentation. And this is probably getting a little bit into the weeds for this particular talk, but chemists love to have numbers and equations. And so one equation over here on the left side is basically showing how they converted the light scattering intensity into the air quality index. And they use this conversion factor of 0.015. That was really only good with relative humidities below 50%. And then we have a sort of crazy equation here on the right, where we were actually using relative humidity to then convert those numbers into reliable values when the humidity was over 50%. And so that's what those two equations were doing. And most of the numbers and plots that I'm going to show you later on are in fact already converted by those two equations. And we use those numbers to do our evaluation of the sensors. And then, it seems like every week something new is discovered. We found even another paper that used a different equation to convert some of the light scattering parameters from the purple air into, boy, I don't know how to say this, but essentially they did a study where they used this more advanced equation, and they were able to get a very strong correlation between what the sensor was reading and the values that they knew they were giving to the sensor in terms of the particulate concentrations. And it was a really, really linear relationship. And one thing that people have been wondering for a long time is the makers of these sensors, they have not published how they do their conversion factors. And so this paper sort of reverse engineered the mathematics behind that. And that was a really nice thing for this retired EPA official in California to do for us, to help us understand exactly how the sensors were converting their scattered light into an air quality index. Unfortunately, I have not had time to go back and reconvert all of our numbers to the new equation, because these little suckers take a data point like every 10 seconds. And when you've had them out in the field for over a year, it's a lot of numbers to deal with. So I apologize, I don't have the newest, latest, and greatest equation updated, but I think the trends that I'm going to show you are still probably relevant. So the first thing we're going to kind of talk about is one of the questions and hypotheses that we had and wanted to ask was, if we put one of these sensors in an area where we don't have a lot of industrial influence, and we compare the values we got from that sensor to one of our sensors, say in downtown Gary or right next to the steelworks, is there a difference? Can we see a measurable difference in air quality? So we're going to talk a little bit about distributions, and what these are is basically graphs that show us an entire year's worth of air quality data all in one plot. So hopefully I don't lose any of you and put you to sleep here, but I think the conclusions are kind of interesting to me. So here is just sort of a little movie that shows all the different sensors that we have deployed and all of their different distributions. And if I can replay the little movie for you, but I want to sort of show you what's on the plot first off. And so on the x-axis, what we basically see is that as we go out further to the right, we have higher and higher air quality indices. In other words, the particulate matter concentrations go up. So the further we have dots out to the right, the worse it is for us as human beings. And then on the y-axis, what we see there is the number of times that we had a measurement that was of that value. And so, since these sensors are taking so many data points every single day, we sort of squished them all together and counted each measurement as either was it sort of towards the 0 range where the air quality was pretty good between, say, 0 and 25, or was it a day where it was a little bit elevated and it was maybe 25 or higher? And so it turns out most of our sensors in Northwest Indiana kind of had an average somewhere around 20 or so. But the differences in the distributions and sort of how long their tails are tell us a little bit of something about the air quality comparison between those different locations. And so I'll go back and we can just see this very first slide, right, shows an indoor sensor that's not outside, and it has a very low peak, very good air quality. And then we can see our outdoor sensors have, broader peaks. They have a larger or higher numerical average in terms of their air quality index. And so you can kind of see all the different places that we had our sensors set up in Northwest Indiana. The last one here we didn't have out for quite a year, but that's why its data is a little noisy. But we're going to zoom in on a couple of these that I want to talk about here next. And so the first one I wanted to show is the one that's right outside my office door, and you can see it from here, sitting out at the university right next to our building. And you can see that the average, seems to peak somewhere around 15 or so. Pretty good air quality, actually. But then, we also have a lot of days that are creeping out here past 25, and then this tail kind of hangs around and drags out for a little while. And that's the air quality, I would say, that's a pretty good proxy for what most people would say is decent air quality. We don't have a whole lot of large industry in Valpo at my university, but it looks fine. Then we have a sensor at IUN, which is right in downtown Gary. And if I go back, you might notice that those two distributions actually look really similar. And in fact, I would say they're almost the same. It was really interesting to us to receive this result. I think it turns out that the IUN sensor was actually, their average was a little bit lower, but these distributions have many, many, many data points associated with them. And of course, they're a little bit noisy, and we are fitting them with a much smoother function. And so there are some interesting characteristics about maybe how we bin these values and stuff that we can look into. But I was really expecting a much grander difference. I was expecting to see a peak that was shifted way further towards the bad air quality side. I was expecting to see a much broader peak. Ultimately, I felt like these two were kind of showing me the same thing. And here's another sensor from the Gary region at Charter School de Dunes. They host one of our sensors. It's actually even better than the air quality at Valpo, which is, it did not support my hypothesis. Let's just put it that way. And so I'm still a bit flummoxed about this, but I have some ideas. So we thought to ourselves, well, let's go ahead and do some pretty decent statistics and statistically test these averages, and let's test their broadness of their peaks, their standard deviation, and running them through these statistical tests. Because we have so many data points, essentially all of them are significantly different from each other, and they're unique, and their differences are real. Now, that's what statistics tells me, but I don't know, there was some wise man quote at some point that if you ever want to tell a good lie, use statistics, right? And so I'm still very skeptical about these results, because I just don't feel like they are a true representation of what I know to be happening in my region. And I know that we have bad air quality because we have some reported results called the toxic release inventory that tell me that our industries are emitting quite a few bad particles into the air, in excess of even what their sort of requirements to stay, within this zone are per year. And so I am not feeling like these sensors are doing a very good job of supporting my hypothesis, which is fine, but also with representing what I know to be the air quality burden that our region faces. So now we can think a little bit about shifting gears. So I can understand that there's a little bit of a problem with maybe the quantitative assessment of my distributions, but is there still something that we can use the sensors for qualitatively that's useful to our community members, that I can sort of point to and say, but the sensors are good for this, even if I'm still very skeptical about their overall performance? So yes, we are disproving our hypothesis, and technically in the wrong direction from the way I wanted it to, or the way I believe that it should go. And I know that as a scientist, when you start using words like belief and things like that, that you are already pretty biased. And I will admit that I have to deal with that. But I think there's some stuff to learn here, and we'll get to that. So we're going to talk about what we're missing. But I think our sensors are still useful from a qualitative perspective. And we hope to improve on that and understand some interesting things that I'll show you now from that perspective as well. So here's another plot that's kind of interesting, where on the y-axis, the vertical axis, again, we're looking at data points where if we're getting sort of above a value of 25, we're getting into a region where we have some not so great air quality, okay? And then on the x-axis this time, though, I've plotted the time of year. So what is the date essentially? And so here we're looking at a plot that goes from approximately late June out to, I don't know, early August or something. And what we see a lot of up and down, and sort of this finer up and down is actually a really interesting phenomenon we call diurnal cycling. So that's day and night. Pressure and temperature go up and down and up and down, and this sort of changes the particulate concentrations in the air. Fine. What we're really interested in are things like over here, this peak, I would say that's somewhere around after the 23rd of July, where we have this sustained high air quality index, where this peak never really comes back down to baseline. It sort of cycles up and down and stays elevated for a while. And if you're curious, the gray dots on this are values before we corrected for humidity. So you can actually see on some of those days, the humidity was kind of high. And once we corrected it down, we still saw these elevated responses. And so we can ask questions like, why did that happen? What was happening on the 23rd of July that caused the air quality to be elevated for a decent chunk of time, more than a day or two? And we saw this again this past summer, where we saw elevated responses from our wildfire smoke. And they were coming, those fires, all the way down from Ontario and Quebec. And we could actually see, when we plotted on the purple air map, like the whole eastern United States, you could almost track it like a river. Those air quality sensors getting elevated because of the smoke trail that was coming from Canada. And my student Abe actually was in Canada while those fires were going, and you can see that sort of in the top right. And furthermore, I think it's of use to our community. Many of you may recall in the lower left here, there was a recent power outage at the BP facility, and they had to burn off most of their product because they couldn't process it. And there were some huge smoke plumes going up into the air during those times. And the sensors could pick that up as well. So there are some interesting qualitative times where we can use them as reporting agents to our community about what might be happening and what might be causing the air quality problems. And so we can look and see from our last summer's data, and I forgot to point out, does anybody have any idea what might have been happening early in the month in July of 2021 here around, I don't know, July 4th? Anybody know what that might be? That's fireworks. So we can actually see particulate concentrations elevated because of fireworks during that time, because they make particulates in the air too. So that's kind of cool. Anyway, so here's our plot from last summer. We've kind of put this green line here at 100 because that's when we really need to start getting worried as citizens about the air quality metrics being above that number. And I've indicated with some flames here times when we had the wind direction blowing the fire smoke down from Canada. And in particular, I'll draw your attention to this time point here that's sort of in late June, right before the start of July. And I will share the following, which is a cool program that we can use to do what we call back trajectories. And so we tell this program where we're sensing the air quality metric to be high, and it runs the meteorology backwards to tell us where the particles came from 24 hours earlier. And on that particular day, this was June 29th of last summer, we can see all of those particles trace right back to where the fires were in Canada. And that's why our air quality was elevated on that particular day. And everybody in the United States has access to this interesting meteorological model. It's called HiSplit. There's a big acronym, of course, scientists love acronyms, but it's a pretty cool program, and I'm actually going to show you how we're using it in some new studies that we're doing later on in our presentation. So now I'll introduce you to our latest set of experiments, which uses our little drone. And I actually, I brought the drone in with me today, so you can see it's a kind of a fun little device that we've got set up. And I don't know, it's probably hard to see because I don't have my screen shared, but right here on top is a purple air sensor. And you can see that on the presentation as well. And what we decided we were going to do is see if we could put our purple air sensor into some of the pollution streams that we know exist in our area. And part of that is an effort that I'm trying to make to say, why wait for the pollution to come to me? Why not just go to the pollution in the first place? So our drone studies are kind of our new hot thing that we're doing, or at least my students think it's cool. I don't know. So this was a study that we did right before Christmas break this year. And we went up to the beach and we modeled some of the current meteorology. And we can show that for the last 24 hours, or maybe this is 48, I can't remember, the particles were coming, from the southwest, and they were heading straight towards the beach here. And then they were continuing on past the beach and over the lake. And we decided to position ourselves sort of right in, as you see on the right there, I've plotted in Google Earth all those particle trajectories heading straight towards our little drone sensor as it was taking a little trip around the beach. And so I made some fun little plots and movies of that particular experiment for you guys to watch. And I think they're on the next slide, and hopefully they play. I don't know how well frame rates are going to work with Zoom and everything, but effectively there's going to be two videos on the top. One is the camera on the drone, and the other one is our drone path in Google Earth. And then on the bottom, you'll see the purple air data that was being collected while the drone was flying around. And what was interesting for this experiment is that probably a quarter mile up the beach before we even got to the spot where we flew the drone, my student and I could smell the plume coming off of the steel mill there, which was really interesting. And so as soon as we started smelling that interesting odor, we thought to ourselves, oh, it's a good spot to fly the drone. And so we flew the drone sort of around and did a vertical profile, and then we went back down the beach where the air was cleaner and kind of came back to our original location. And as we did this, you can kind of follow the little red line as it plunks along on the bottom there, measuring our air quality. And at first it starts out pretty low. And then as we kind of start to elevate ourselves up a little higher, that starts to go up a bit. And you can see some of the smoke plumes coming off of the steel mill there. And then we have some interesting things happen where it drops back down again. And then as we start heading out, it increases. And we're sort of trying to digest this information a little bit still in terms of how long do the air particles stay trapped in the sensor. And maybe there's a bit of a delay in terms of where we are located and the actual particles that we're sensing. So that was kind of a fun little experiment that we ran recently. We also did some studies to make sure that it doesn't matter which way the wind direction is coming into our sensors. So we ran some studies where it was upside down and sideways, and we even tied our drone to a table so it couldn't take off and turn the propellers on to make sure that the propellers themselves weren't really influencing the particulates that we were measuring. And in both cases, I was actually quite surprised that the values compared almost exactly with our stationary sensor that was sort of off to the side here from these experiments. So hopefully in the future, we're going to deploy some new devices that are actually even better at measuring our air quality metrics. And we can do some collection of the particles rather than just sensing them and recording numbers. We're actually going to collect them and bring them back and analyze them sort of off-site. And then we want to also try and make sure that we have a good website set up to give feedback to our community about events that we might see qualitatively. We're going to continue to use our high split model and our drone to track our particles as best we can. I brought in for show and tell actually a couple of the other types of sensors we have. And once I end the presentation, I can show those to you guys here in a minute. But we're going to continue to evaluate these sensors because I think the take-home message that we're learning about these sensors is that they're good for some things. They're great for fire smoke, but they may not be good for larger particulates that are kind of really big and don't get up into the sensor. And they're just terrible at molecules. They aren't designed to sense molecules. And so molecules that are often associated with some of the odors that we have in Northwest Indiana, they're just really not good at sensing those. And so we need to keep that in mind. And so here's a picture of some of the sensors. I brought them in. You can even see some of the particles being collected here. Each of these lines represents a particular event in time where the particles were really bad. You can see that they're black, which is probably telling us that they're combustion products. So that's really interesting too. We also have a new satellite that's gone up into space. I don't know if anybody's heard about this, but it's actually doing a really good job of sensing air quality by doing some scans, spectral scans of the country. So that's really neat, and we're excited to see that happen soon. And here's kind of a little, I think it's a little video that shows if it plays. Oh, it's linking out to a video that's I'm not going to be able to share. So anyway, check out the Tempo satellite if you want to see some cool stuff. And then, of course, I'd like to thank all the folks that have helped me out with this, my collaborators, Dr. Peller, who's with me here at Valparaiso University, and Dr. McCool, who's in the geology and meteorology department, Dr. Ken Brown from Hope College, Dr. Graham Peasley from Notre Dame, Ellen Wells, who's our collaborator at Purdue University, and Jody Allen, Dr. Allen from Purdue University Northwest is also part of our team. You can see some of us and our students out doing some data collection this summer here. Of course, our funding agency, the National Institutes of Health, and the Indiana Space Grant Consortium. It's been a fun ride, and we're just getting started. So I think there's some cool stuff happening. Anyway, I will stop there, and hopefully I didn't put anyone too badly to sleep, and happy to take questions from anyone that has them.
Are there any agencies that are doing current air monitoring, like EPA or others, in the area right now?
Yes, there are. And in fact, most of the air quality sensors in our area are administered by IDEM, the Indiana Department of Environmental Monitoring, I think. But the EPA also takes their values and catalogs them. And the only issue that I've run into recently with those is that it's the database that they're stored in takes some pretty advanced programming to be able to download the data points. I really want to compare them to our purple air sensors, but I haven't quite gotten all the scripting figured out to get those values downloaded. It's also true that the sensors have changed over time. So they've moved or changed locations, or they've been taken in and out of service. So you kind of have to have a good pulse on what's been happening with our local sensors, but they are there. I would make the critical comment that if Purple Air can make a map that puts numbers on it for people to look at, then I really feel like the EPA should be able to do the same. And I would love to see that happen.
Oh, do you hear me? This is Carolyn Marsh.
Hi, Carolyn.
Hi, nice to meet you.
You too.
And even if it's on Zoom, I
Yeah.
appreciate you coming out and giving us a background on this.
Sure thing.
My concern is that, I live in Whiting and
Mhm.
am deeply involved for 30 years in permitting and of all the industry that we have here, which is steel,
Mhm.
refinery, and chemical, all together. And I was wondering how I could get one of these monitors at my house
Oh,
on
well,
Oliver Street,
come to the right
because
place.
wait a minute. I don't want to pay for it. I was never offered a monitor. I live by Whiting School, and there's diesel buses parking there. And I try to get the school to stop idling, and that's not happening.
Mhm.
So I have a COPD now, which I
Okay.
didn't have before. And I would really love to get a monitor at my house where the school kids are coming, the grade school kids, the high school kids, and the bus and the street, the car traffic is really packed during school hours coming and going. The streets are just packed with idling cars.
Yeah.
So I would need these statistics to get some movement going among the city and the school to show that we need some help here because these kids are going to have asthma and they're going to suffer a great deal if they're not already suffering from asthma and other breathing issues. So that's one thing I really would like. The other thing is where's the monitor on Superior at the bike trail? It's not just on the bike trail. Is it in a house? And who owns that house? I think
Well,
the one on the other one is on Susan Duncan's house, if I'm not mistaken. But the thing is where you locate these PM monitors is very important because you mentioned the school at the charter school. Well, it's on the lakefront. I think the school you're talking about is at Miller Beach. So it wouldn't, that would answer why the pollution isn't registering very high if you're on a beach, near a beach. And so these monitors are where they're located is, I think, key to understanding who's suffering the most and how we can make those corrections. So where is the address? Well, who owns that purple air monitor on Superior at the bike trail in Hammond, Indiana, the George Lake Bike Trail?
so I can tell you that we have some community members that have them. I believe that one might be at David Daberton's house, I believe. I'm not entirely sure if that's the one you're talking about, but
Well, that sounds like right, because he's right on Superior, but see, he's by a lake.
yeah.
So, I don't know who picked these areas, so I think there needs to be a community involvement, which there hasn't been in Whiting at all. Of that, first of all, there's monitors available that we don't have to pay for, because when I got on that purple monitor air, it says, "Hey, why don't you buy one for
Right.
$300?"
Yeah. And so
That disturbed me.
I would love to comment on a couple of points that you made that I think are wonderful points. And the first is, where these sensors are located. And it turns out that being that we live so close to the Windy City, the air around here is very windy as well. And so it tends to mix pretty quickly from what we've seen. And we can see that as the wind progresses across the region, we can see our sensors sort of pick that up. But in terms of the localized effects, like you're talking about in your, on your block where you have an air quality issue, you're absolutely right that a sensor that's maybe even 3 blocks away won't pick up the same particulate concentrations that would be necessarily on your block. In some situations they can, but then in other situations they won't. And so it is highly variable. Our sensors are being deployed as part of our grant across the region. And so this last summer, we were really focused on the Gary region, and we're going to begin moving our sensors this summer into East Chicago and Hammond and Whiting. And so I would love to get in touch with you and have a chance for you to host one of our sensors if you'd like. I think that would be really awesome because we need our community members involved, and we need our community members to give us information about where there are air quality problems so that we can, get our sensors in good spots. And I will tell you that, even even some of our fancy sensors, I would like to get in good spots too, so that they can also measure along with the purple air. And so this is like a $15,000 sensor And unfortunately, I deployed this in a bad spot this last year and it sucked up a bunch of snow and it broke on me, but I got it fixed. So we're looking for community members. We want you to be involved. We want to hear about where you're having issues, and you are more than welcome to volunteer to be one of our hosts, and we would just love that. So yeah, that is exactly the kind of relationship with our community members that we are looking for. And that's how we've come to put some of our sensors out in the Gary region. And we hope to continue that, obviously, as we move into the other regions of Northwest Indiana. So,
Well, just to wrap up my concerns, I'm the administrator with Pat Walter of BP Whiting Watch. So
Mhm.
it's a Facebook, and we really do circulate information and try to educate people. And I'm a moderator for SWAN, Save Whiting, and Neighbors. And it's called Swan because of swan deaths on
yeah, I
George Lake.
remember that. Yeah.
Yeah, well, it's still going on for 5 years, but in any case, we're real busy. And I really appreciate the invitation because I'm very, we have a lot of sick people here and I really want to help them as much as I can because I think I've been in the forefront of monitoring what's going on in the community as a bird watcher as well,
Yes.
monitoring the birds and what the effect on wildlife is important to me, and I'm educating a lot of people of all the great wildlife we have here. You know, we have an eagle nesting on Calumet Avenue in the Indiana Harbor. So there's an eagle nest active there. So there's a lot of things here that we could have if we can get more control of our environment and make it better. And I thank you for the invitation. I really appreciate it.
Yeah, that would be awesome. Thanks, Carolyn. There was a question in the chat about how do we use the charts that are created from our purple air sensors. And so what we're trying to do is we're getting a sort of a nice public facing website up and running where we can post kind of our yearly charts so people can see and begin to kind of keep track of sort of like what their air quality looks like over the span of a year, and then they can compare year to year, or even if we can do it month to month, sort of like what's going on in their area. We also have, I was gonna show you guys too, we have some of these other particle sensors that we've been looking to put out at different locations too, that are good to compare to the purple air sensors with to make sure they're measuring all the particles. And these sensors are basically they're like a purple air sensor, a really good one, with a filter. And so not only does it measure the particles, but it collects them. And then we can bring the filter back to campus and we can study what particles are present on the filter and make sure that there's an agreement between the amount of particles counted and the amount of particles deposited. So that's kind of a really nice thing too. Okay, here's another question. Is Purple Air a better technology than Air IQ? And I'm not super familiar with Air IQ. My assumption would be it probably is a very similar device, and I'm sure works just as well as Purple Air sensors do. They're basically all sort of a light scattering device. If it's one of the smaller, cheaper, I mean, cheaper in quotes, portable devices. What I will say is just that the purple air sensors are really good at what they do, but what we should be caring about as a community is a broader range of air quality issues that the purple air sensors do not cover. And that's where I really think that we need to advocate as a community for our policymakers and our governance entities to be using the resources that they have to set up good sensors that measure across the spectrum in multiple places. So I might not have mentioned that sort of as my grand conclusion. I do really appreciate what the Purple Air sensors do or the Air IQ sensors do, but it's going to be limited. And I want to see us still thinking about all the air quality problems that we might have as a community.
Sean Conley, did you have a question?
No, I don't. If I had my hand up, I'm sorry.
Terry, it looks like you have a question. Go ahead.
Yeah, I was just wondering if like BP was supposed to do fence line monitoring and stuff, and I was wondering if they are doing the fence line monitoring already, and who is that provided to? Because I'm sure they have better required to have better monitors than what the purple units are, correct? And then
Yeah,
the steel mill is the same way.
I
And
would
then-
assume. Go ahead.
And then you have this little spot in East Chicago called Marktown. It's surrounded by BP and the steel mills and the chemical companies. Well, what are they doing offering to help monitor those folks that are probably in a toxic pool?
Yes. Excellent points. I would say I have a couple of responses. First off, I am not familiar with exactly what BP is doing and what BP is required to do. I am fairly certain that whatever it is, BP probably operates in excess of those requirements, meaning that they're emitting more than they're supposed to be emitting. But I do not know if their sensors are particularly appropriate for detecting all of the things that they emit from that facility. I don't know how many of them they have. I don't know where they are. And I certainly don't know who they actually report those numbers to. And that's some of the problem that we have when we have self-reporting entities that are the same people that are emitting things are reporting what they're emitting. I really feel that there's a conflict of interest there that we need to address as a society, because I really think it's better to have those things housed in separate places. That's just my sort of personal opinion about maybe the best way to do it and remove a conflict of interest. But the other thing I would caution with those sorts of sensors, and especially this is true with ground-based sensors, those smokestacks, they are very, very high up in the air. And a lot of times with the way that our weather works, a sensor that's on a fence line may never see any of that. And so that's where my drone is really kind of interesting, because what I'd really like to do is get into the plume itself and see what we measure, because I really think that might actually be a better way of doing this. And to be honest, we could put sensors on smokestacks. This is not a problem. And in fact, it can be done. And that would honestly be an even better way of doing and understanding what our emissions are. So, we could do better is what I would say. And probably what we're doing now is not great, and it's not well reported, and it's probably exceeded even then. That would be my guess. My hypothesis. I can't prove it, but that's just sort of my historical understanding of how industry operates. Typically, that's how it goes. But you are absolutely right in all of your points. Susan.
Hi, Chris.
Hi, Susan.
David, could you turn off your volume? This was really great, Chris, your presentation, and I'm so glad that you are coming out from the partnership to share with the community what you're doing, and also that you're being completely open about the complexities of measuring air quality with devices of all sorts of different types.
Yes.
What I wanted to point just briefly to what Terry just brought up my understanding is that those fence line monitors had generally have been set for PM10, so a larger sized chunk of particulate than PM 2.5.
Mhm.
But again, this is rumor and hearsay.
Yeah.
But the thing I'm puzzling over something in your presentation, and
Sure.
I want to put out into the conversation a couple of things. First of all, the purple air monitors, as you say, are very particular in what they do. The particulate that they're geared to, as I understand it, is 2.5. So larger molecules like pollen and whatnot are not going to trigger.
No.
Right. So, but for what we're talking about here, I think most of us are not so concerned about pollen. We're really concerned about what's coming out of BP or out of the mills or whatever. Furthermore, environmental science is showing that if you do have measures of PM 2.5, you've got the measure that is really of the bad actor that is of most concern and does does associate with most of the health effects that we're concerned about. That said, yes, you want to know those particulates, what exactly are they? What are they carrying? Are they carrying lead? Are they carrying other toxic heavy metals? Something else? You do want to know that. And for that, you do need to go to a better grade of sensor that's got a filter in it that'll catch them so you can pull that out and do chemical analysis. Okay. The other thing I want to say is there are purple airs and there are purple airs. There's the type that does detect volatile organic compounds. So if you have a purple air with an SD card, you can pull it and you can look at levels of volatile organic compounds, which I think does get us into the area of concern of people living in Whiting near a big plant that's burning off hydrocarbons and whatnot. Okay, so now what I'm puzzled about.
Sure.
The first portion of your presentation, you seemed to want to say that maybe purple airs are not very accurate because the readings that you're getting at with ground level purple airs over there in Gary are not what you expected, are not really effectively what you know to be true, that sometimes the air there is really bad. So why aren't the purple airs shooting up into the red range? But then you tell us about your really cool, I agree with your graduate students, drone-based research where you're flying the purple air up into the air and you're putting it right in the middle of where you know some bad stuff is. And lo and behold, purple air is measuring bad stuff, right? So it seems to me that if you put the purple air where it needs to be, it's going to do its job for you, right? It is giving you reasonably informative stuff about air quality. Am I right to be puzzled or am I missing the point?
No, it is. It's always one of those things that's just rife with nuance, I guess. But from what I would sort of estimate, the air quality burden is in the regions where we have the sensors, even if they're maybe not exactly in the right place. I would have expected them to pick up much higher amounts of particulates, and I don't have the data yet to prove that. I only have data from previous studies that I've done where we've had some of our filter collectors next to a railroad, and just being next to the railroad, you could see when the trains were coming in, what time of day. You could pick up those particles. And they were quite high when we did our conversions. They were quite high in terms of their air quality indices.
Okay.
I'm not seeing those same sort of spikes from what I would consider to be much worse actors in terms of air quality pollutants. And so it is picking them up. When we had that drone on the beach, for instance, Abe and I, we could smell strongly what was coming off of the steel mill, what was coming from the slag that was being dumped, and those sorts of things. The air quality index never really got much above 70 on that drone. And in fact, if I use the other conversion factor, I think it actually gets even lower.
Mhm.
I could smell it. My eyes hurt after that experience. Right?
You know what? I can say that our purple air was going really high when we had BP burning off all those hydrocarbons. It was up, it
Right.
was elevated for a week, up into the red zone. So,
Mhm.
and that was true of all the local purple airs that are around here. And
Right.
I don't think anything else was happening to fire them all off. It was the plant. So
Right.
I
So
do
they
see it up and down on the purple airs based on stuff I see with my eyes, things I know is happening. So I guess I have more confidence in the purple airs and what they measure and what they can do to inform communities about what they're breathing, maybe than it seemed you were expressing at the beginning of your talk.
Yeah, and I think that if there's anything that we have to be most concerned about with the purple airs, I really feel like it's false negatives. I think when they detect something, there's a problem. I really believe that's to be true. I maybe question, there's a big difference between an air quality index in the red zone of, I don't know, 100 to 150
Mhm.
and 300 and 400. And my concern is just, is it really accurately measuring how bad it is?
Ah.
And I know from a chemistry perspective, I am so excited for that volatile organic sensor that the new purple airs have. I
Mhm.
wish they would release, some sort of announcement that says these are ready to go. We've calibrated them,
Mhm.
go for it, because I think they're going to sense not just volatile organic carbons. I think they're going to sense, some ozones. They're going to sense a lot of those small molecules that I'm talking about we're missing, right? And I want to see some calibrations done by the company on that so that we can have at least a starting point, for being able to rely on those. And so uh, I do think that the purple air sensors, they worked amazing in fire smoke. I think they work great in combustion stuff like what was coming out of the Whiting facility during the power outage. I just don't know that that translates to the really small stuff,
Mm.
molecular stuff, and that's what that other sensor might be good for. And I still think we need to be concerned about even big particulates too, which I don't think that they've ever published and said they do a great job on,
No, no.
which is fine, right? Like that's it's one, you just need to know the limitations. And so I'm still just a little bit hesitant to like, I don't want my community members to think something is okay or something is maybe just, not great when it's really bad. Like I'm super cautious about that for some reason. So I don't want to say that I think they're amazing and they do a great job for what they do. We have a very broad spectrum that I'm concerned about, and um so yeah, it is confused. It's very confusing probably to listen to me kind of go back and forth about, well, this is good, but this is not so great, but this is not really there, but this,
We're all learning.
it's nuance, right? So but you're absolutely right. They do really good at the combustion stuff, in my opinion. I think that they hit that kind of on the head.
Okay, we have two with questions. Jenny was first and then Terry.
Sure.
Yeah, thank you for this. It was really helpful, and I am also surprised by your results. Um, and I wanted to, I guess, ask a clarifying question. When you mentioned moving and expanding in the region, are you going to take down the sensors that you currently have in Gary, or are you just adding more sensors to your inventory?
Unfortunately, it's going to be moving them. I don't
Okay.
I don't have enough to kind of keep them all in the same spot. Now, that doesn't mean I'm going to leave Gary with no sensors at all. I'm probably going to leave the ones that I have in sort of my best locations.
Mhm.
And then some of the other ones, like I know I have one at Dr. Peller's house in Chesterton. I can probably move that and she'll be okay.
Yeah.
And there are a couple others that I can move to. And as Susan said, some of these newer sensors that have the VOC detector, when we get some more standardization with that, it would be great to have new sensors to put out that can measure that too. And so I'm kind of trying to dig around for some more money so that I don't have to move everything and try and get some new sensors up in new places that are kind of the better sensor. And then also I want to deploy some of the ones that I have that are like the really nice, really expensive ones too. So yeah, I would love to be able to give everybody a sensor. Like, in fact,
No, sure.
it's
I
been
get
my
that. I get that.
dream, like get one of these on the top of every middle school in Indiana, and they can all middle school kids can have it as a science project for, sixth grade or fifth grade or something. And we've just got the whole state is kind of covered in them. I think that would be so cool, and not very expensive for our state to sponsor something like that. And, for all of my, concern about what purple air sensors are and aren't good for, I certainly know that a purple air sensor is better than nothing. Absolutely. So yeah, that's probably how things are going to go. But
Right, right. And I just wanted to kind of add to what I think some people have already been saying, some of the community activists is, and I don't need try to answer this now, but I'm kind of amplifying this um this ask that as more of an expert in this field, if you're able to help us better define like what we should be advocating for when we go to meetings with IDEM or EPA or the polluting industry, because fence line monitoring is kind of like the buzz thing. And so I've heard a lot of people advocating for that. But if one, it's missing things because it's not high enough, or if there's a specific type of monitor, we should be advocating to be at the fence line. All of that would be very helpful so that when we're advocating, we're doing it, in the best way to get the best result possible, in terms of being protective of community health. So any more information you can send like via email or something. I know we have IDEM is holding a hearing on US Steel Gary Works at the end of the month, like the last month. So I know people will be out and we'll be saying these same kind of things, but if there's more specificity that you're able to like direct us to, I would really appreciate that. So thank you for the work you're doing.
Thank you. Thank you for that. And absolutely, we formed this partnership with the intention of being in relationship with our communities and our community members as a resource. So I really actually wanted to make it to that meeting at the end of the month, but I'm teaching lab that night, unfortunately, so I'm not going to be there. But I think that is absolutely true. Like, if you guys have questions, email anytime, and one of us will try to get back to you as soon as possible. And we're headed out to Whiting middle of the month. I don't know if you saw the announcement to help do lead testing on people's soils that are now caught in this new Superfund site. And we're trying to be as absolutely involved as we can. And I was recently chatting with oh goodness, I'm absolutely blanking on names, about sensors at one of the mills and how that could be done, and gave him some information on different types of sensors that are available. So we absolutely can do that. We would love to help as much as we can. Whether or not that moves the needle towards better sensors or better sensing in general, I don't know, but I'm happy to, my brain is your brain. I don't know if that's a good thing or a bad thing, but
Okay, we have two questions, one from Terry and one from Mario. Terry?
Yeah, I'd just like to kind of intertwine some of the things we've done here. One thing, I'm learning about this monitoring that it needs to be done in a specific way with specific instruments in a specific place. I think, if you look at the steel mills, BP, rail yards, bus barns, all these things, if these people that manage these operations should have what they call a little social responsibility and environmental responsibility to the people in the community, that we need to make that basically a proposal to that whole group of people of what they need to do as far as monitoring air quality. And that might solve your problem on gathering data, because if they're required to put these on the stacks and then the rail yards and the bus barns and wherever else that is determined that we need to do the bit more monitoring, it would, then you get that baseline of data that you're looking for, that's a little more inclusive, and you know exactly what direction to go. And recently, BP just got a consent decree on them, and they had to pay $5 million to four cities for trying to do something to decrease the carbon footprint. And so they each got $1.25 million. They're supposed to be having a committee from each town that they're meeting with. And so we probably need to engage, especially those four cities, Whiting, Hammond, East Chicago, and Gary, to be more proactive in the things you're talking about as far as the monitoring system. And also, we've had some great help from some of the organizations that have represented these people in these consent decrees with the Environmental Law and Policy Center and things like that have done some great things to help the average person out and to get these consent decrees. Now we just need the technical aspect of it put into place so that we can get some proper results and proper remediation at the proper time instead of just getting abused constantly. So if we can think about that bigger picture, and you're the scientist, so we'd like to kind of dump that on you as far as what do you need to make this thing work? I mean, you take the ideal picture and make it what's the perfect scenario, because the steel mills, BP, they got plenty of money, just a matter of where they're going to put it, in their pockets or in the community. And I think we got to make them realize, you're in our neighborhood, you got to have a little corporate responsibility and you got to have a little environmental responsibility, and we can make those arguments and develop that cause. And because you're struggling just to do things with the purple monitors, and we should be giving you the stuff you need to do effective monitoring in an effective way that benefits everybody. The world, in fact, is what it does, because there is this thing called climate change. So we need to make sure we acknowledge where we're going and fight for that if we have to. And thanks for all your information you've provided us.
Yeah, thank you, Terry. And I appreciate those comments. I would probably even take it a step further and say that, my vision for this region, right, is to have these companies working with communities, having more jobs, being more involved in creating a safer, healthier environment through that job creation. And it's hard sometimes. I get pretty discouraged because I'm trying to do a little bit of information feedback to our community. And it seems really silly to me that when a lot of the major offenders are self-reporting that they're exceeding their permits, like why do I have to find a number to tell them that? Like, they already know this. And so I would love to work with those companies as a community and talk about how we can do better. We obviously can. And I would love to not have to put out a sensor because we're operating in a way that's healthier for our environment in the first place. And they have I have a really hard time, and this is me getting on a little bit of my personal soapbox, but I understand that large corporations such as, the entities in our region, make plenty of money. Okay. And we don't need, uh, we don't need certain individuals, at the top of that pyramid taking home really big paychecks. I think it would serve them much better in their community to be putting that money back into their infrastructure and back into the people that are really influenced by some of the decisions that they make, um, to make the world a better place. But I'm kind of an eternal optimist, and I realize that wheels turn slowly, and I have to be patient, and I don't want to be patient because I talk to my community members all the time that are sick, that do have asthma, that have COPD, that have cancer, and for the most part, there are reasons. And I know that that's not every case, but I have heard too many stories to not recognize that the historical burden of pollution in this region has to be part of that equation. And so I would love all of that to be better. I don't know necessarily where to start and how to move that needle. I just know that I've got maybe a little tiny thing that I can maybe do a little bit better in my little sphere. That's what I'm kind of going with at this point. But everything you said is right on the money. So thank you for that.
This is Carolyn Marsh again. I'm very shocked that you're coming to Whiting to do lead testing at Federated Metals, and I don't know about it. I spearheaded that whole to get it listed as Superfund. There was
Okay.
quite a lot of there was a lot of opposition. Dave Daberton was on the opposite side. He said nothing's wrong over there at George Lake. And there was a lot of divisions created, but finally we won out that the federal government had to step in and not only clean the communities, the residential area, but also George Lake. So when you're out here, I mean, I don't know how many people are studying things because US EPA is supposed to study it. Now you're saying you're studying it. How many different entities are studying it? And why is that? I mean, are you hired by EPA to work with them to do their studies? You're separate. Why are you funded separately? Where can residents go to get educated when there's all these different partnerships going around and the community residents who actually live here, beside Dave Daberton, who seems to know everything, we really want to educate ourselves, and we can't
Yeah.
do it when we find out there's all these different partnerships going on and different agencies involved. And you're coming into Whiting. I'd love to see you there. I don't have to.
Oh, yeah.
Obviously, I can't get involved, but I'd like to take a few pictures. You're out there, for the
Well,
Facebook. So, please give me more information on that
yeah,
offline if you don't
I
mind.
I absolutely understand your frustration, and I'm frustrated by it too sometimes because I want to know all the people that are doing awesome stuff in the area as well, and I want to be a part of supporting them and supporting their efforts also. And so I apologize if word hadn't made it around. We talked to a few people that seemed to be interested just because the EPA seemed to have like a longer timeline before they were going to get results back to folks. And we are in no way an EPA certified lab. I think we do a decent job, but in terms of getting people a little bit of result information a little bit ahead of time, we tried to, listen to folks that had that request and, figured, hey, we can show up on, I think, what did we pick, a Saturday or something like that? And, just set up our little instrument and collect some samples with them and do the best job that we can, which is by no means as good of a value as the EPA is probably going to give people. But again, that takes time. it takes longer. And some people were kind of really concerned about having to wait that long. So I think it as best as I remember, that's kind of the story on that. And that is traditionally how we try to operate in the space that, if people reach out to us and they're like, have a concern and we can do something, like we can help a little bit, then we'll definitely try to do that. So I'm happy to send you an email. I think that Calumet College, St. Joseph's had a little flyer that they just emailed me yesterday that they had sent out, and I can absolutely send that along. If you want to put your email in the chat, I can make sure I email that to you or something. But yeah, I am all about forming relationships and being in relationship with people and working together. And I am not an enemy maker. I need friends. I need people working together. So I definitely, I don't want to step on anybody's toes. And I also don't want to, leave people feeling like we aren't helping them if we could. So I understand the frustration though. It's hard sometimes to make sure everybody gets all the information that they need. But the upshot is if somebody doesn't hear about it and doesn't get out there for that day, we're more than happy to send them it's basically a little Ziploc baggie, and you could just put your soil in it and mail it to us. We're happy to come back again. Like we're not going anywhere, I guess is what I'm saying. So hopefully we can help meet the needs of our constituents as best we can and move forward with everybody. Hopefully better things a little bit. So
I just might add that we have a tremendous opportunity at George Lake, which is right near BP. I mean, the picture on the website on the fact sheets of the law firm ELPC was over George Lake, looking at the smokestacks coming out of BP. They're very close. So we have a tremendous opportunity to tear down Federated Metals and clear it for green space. But I heard that EPA is saying, no, they're not going to tear the building down. They're just going to clean it and reuse it. And we don't understand things like that. So, but there's tremendous progress can be made in this area of Whiting, Hammoney, Chicago, in particular, where we have the most concentration of industry. Gary doesn't have the concentration we have. And it's unbelievable when you look at the map. So we have an opportunity with it being a Superfund site to get the right result done, the long-term result done. And your studies and letting us in on what you're doing is really going to be helpful to put pressure on the politicians here who kind of like the gatekeepers to the industries.
yeah, well, I hope so. I hope we can work together with our policymakers, and I hope we can work together with our industries. And I know that there is a long history of adversarial interactions there, and I get that. And I also have to respect that as well. But if we're going to move the needle forward, we've got to all get on board and do our part here. So hopefully that you know, hopefully that happens.
Chris, do you have much longer today, or shall we call it quits?
Uh, I've got time if people still have questions, but if people are tired of hearing me ramble on and really not say anything definitive, then that's fine too.
Any questions?
You might want to see if Olympia would say something. She lives in East Chicago, so that would be a good benchmark for getting some feedback from an East Chicago resident if Olympia would say a little something.
Awesome. Hi, Olympia. It's nice to meet you.
Hello, nice to meet you too. I just came in late to this talk and I was just here to listen to see what was going on. I do
Oh,
know
cool.
that the soil contamination is a concern. I live pretty close to the newest Superfund site. I think it's the newest. And the air quality is also a large concern. So I
Yes.
personally am concerned and want to get my soil tested because I don't know what's in my soil and I do a lot of gardening. And what if I'm just poisoning myself by eating the food that I'm growing?
Yes. That's exactly the sort of questions we want to help you answer. How is the soil in your garden? And as a baseline rule for Northwest Indiana, I would highly recommend that anyone, it doesn't matter where you live, use a raised bed and get your soil from somewhere safe, because it oftentimes there can be issues with soil quality for one reason or another, and it's really hard when you have a century of previous issues to know what necessarily has gone on in the soil.
Yeah.
So yeah, but please get in contact with me, christopher.iceman@valpo.edu, and you can send us a little Ziploc bag of your soil where your garden is at any time, and we'd be happy to test that for you. And we can tell you sort of like what metals are present. It's a little bit harder for us to tell you about other things like there might be hydrocarbons from oil spills or things like that. That's a little more difficult for us to do, but we can certainly get you the metals information. And from all the citizens we worked with in East Chicago, and in particular zones 2 and 3 of the Superfund site, there was definitely reason to be concerned in a lot of those
Mhm.
cases.
Okay, thank you. I will
Absolutely.
be contacting
Have a
you.
question, Pat?
Hi. Yes, as Carolyn Marsh said, she and I are partners for the BP Wedding Watch. And so one of the questions that came up in connection with the latest air permit with the BP Wedding was just how many air monitors EPA has. And we found that there was only 2 in the general area, and neither one of them was close at all to any of the big industries that you were talking about. Like the one is on East Chicago Marina, which is nice for the marina, and also somewhere in Hamlin by the 141st Street. So I was wondering, we were also part of a webinar on March 15th with the Environmental Law Institute, and they were talking about how important purple air monitors are and how valuable and reliable. And one of the gentlemen on the webinar from EDF thought that that the purple air monitors should be considered along with the EPA monitors. So they like them.
Oh, I like them too, especially along with the EPA monitors. But isn't it interesting that you've noticed there are only 2, and isn't it interesting that their location is sort
it's
of
not hard to find, but like I said, on this EPA webinar, or the ELI webinar about the new EPA soot standards that we're all concerned about, which are great. The gentleman from EDF, I have his name, he was talking about how the EPA should, shall we say, move a little bit quicker, which would be really nice, and simply incorporate the purple air monitors, which from my understanding is that they only monitor, like you said, the PM 2.5. They do not do any volatile, they don't do any chemicals, they don't do anything other than what's in the air at the level of PM 2.5, which are small and dangerous, very true. But I think that's part of the issue. So I was wondering, are you folks working with the EPA?
we have tried. So there have been a couple folks that have sort of responded when we've sent emails and called with the EPA, but the EPA is somewhat limited, I would say, in the types of relationships that they can formulate with community entities like what we have. And I understand that. I understand that there's policy, and I understand that, you know, they have to kind of keep their house separate. I would love personally to see a more collaborative, cooperative effort moving forward. And I could have plenty of suggestions for them about how that might work. But yeah, it is also a slow process, and we haven't really made a lot of progress in that area, in particular with working with EPA. And you know, EPA has these regulations for a reason. They have a limited budget. That budget is limited to the projects that they have approved to spend that budget money on. And their policies in terms of how they test and what they test are sort of in equilibrium, let's say, with their budget constraints. And my personal feeling is that the EPA in this country has way more problems than they can address, especially from a funding standpoint. And we would have to, as a country, really decide to put a lot more money into the EPA program to actually really do a good job addressing problems the way they need to be addressed.
Well,
and so,
sorry, but from the
go ahead.
webinar, Peter Zalzal, Z-A-L-Z-A-L, who is a distinguished counsel and associate vice president from the Clean Air Strategies of the Environmental Defense Fund, he agrees with you. So sometimes it's not a bad idea to consider working with, shall we say, well, other groups.
Yeah, you know, let's just say that it's going to happen at some point. It hasn't happened yet, but I look forward to the day in the future when we are working together and collaborating. And that, you know, I think there's also a history of the EPA not really listening to constituents over time. And that was especially true when we were working with our community members in the East Chicago Superfund site, right? And so there's a lot of nuance there. EPA really needs to hire a bunch of social workers to be on their staff to help interface with communities, right? Like that is a huge part. Communication, like that is one thing that I am struggling with so much. Like I'm a scientist, but I need to spend like 90% of my time communicating and talking to people and helping them understand things. And that's a very different role than I was sort of trained in, which was, you know, sitting in front of an instrument and collecting numbers and diving into all the details. And so there's a lot of holistic issues also, I think, that are part of that. And I would love to see all of that move forward. And if I had the ability to push the button and increase people's taxes, I'm sorry if you're against it, but you know, get some money back into the system, maybe not spend so much money on some other things that our government tends to spend a lot of money on and put it towards some of these problems. I would love to do that, but it's going to be a progression, I think, from what I understand.
Can I shift gears just for one short second? Sorry, but in the shorter term, shall we say in the near term, would it help at all to have air filters distributed?
What type, like air filters for people to breathe through, or air filters to collect
at their home, home air filters?
You
because
know, and actually,
that's another expensive question.
I was really kind of a big fan of some of the barriers that came down during the pandemic in terms of people wearing masks. And I have actually mentioned to people that if you are on a day where air quality is really bad, and it seems to be a little bit more socially acceptable to wear a mask, and you have, you know, asthma or whatever, by all means, put on a N95, right? That is going to help. So yeah, absolutely.
I'm speaking of the home air filters, not the personal.
Okay, yeah, home air filters can also be very useful because it turns out that air quality in the home can also be just as bad or worse than it is outside for other reasons. But yes, air filters in the house can actually be pretty good at helping, bring down a lot of those air particulates. There are also lots of ways to help decrease, air pollution in your home. And I know there's been a lot of recent publications about gas stoves and some of the air particles that are created from those. Having a clean air filter in your HVAC system. I mean, I'll be the first to admit that, my kids drag a lot of dirt inside. And sometimes when I vacuum the house, I put on a mask because I end up sneezing a lot less. So, it helps then too. Yeah, but that is also of concern. And I don't specialize in that, I wouldn't say, but I've certainly read lots of papers where indoor air quality can be absolutely atrocious.
Thank you very much.
Yeah, you bet.
I would just like to, this is Carolyn Marsh again. I would just like to add that one of the issues I've had is following the permits and what BP and Steel, what kind of monitoring they have. We need a central place where somebody does a collection of all the data of what right now exists. Like you didn't know there was only 2 monitors in East Chicago, or that we know of. We need to know whose monitors they are. Are they IDEM monitors? Are they EPA monitors, the quality of EPA for chemicals and everything? Are they air pollution? Are they just for benzene? This is what we don't know. And where are they? And where they are, what are all the different types of monitors? We need a chart on that, because we can't really have a good opinion on what BP should be doing if we don't know what really exists there, and we don't know. There are no fence line monitors. There were for benzene. I don't know if they're still there. So one chemical, benzene. But in the discussions on the air permit, we're fighting very hard for real-time air monitors for the community to plug into real time. BP did have at one time fence line monitors for 3 years under the Calumet project, which David Klein should know about. But they only had it for 3 years and they controlled the data. And I told BP at one of their sessions that we don't want you controlling the data. You collect the data, it's their property, it's their industry, but we want that data to be real time and circulated without any holding it for a month, and for them to have, it's their private, data. It's got to be made public, the data, so that we know if we should stay in our homes or get out of our homes or get out of town. We need to know that, because BP was ready to blow on February 1. I was out there, and we need to know what's going on at that plant in particular.
I couldn't agree more. And I know I can assure you that if a startup company with little $300 sensors can do it, then I absolutely believe that our government or our industries can make that happen.
Well, any other questions? If not, Chris, I'm just grateful that you were able to stop by. Thank you very much.
Thank you, Michael.
And is Valerie still here? No, she's not. But anyway, she and I thank all of you for attending this evening's gathering. I got a lot out of it. And again, Chris, thank you very much.
Well, thank you so much for having me, Michael. And I hope at some point I can come back, or one of my colleagues can come back, and we can talk about the soil sampling and the water quality. That would be phenomenal.
Let's do
But
that.
thank you all for having me.
I'll hold you to that.
For sure.
Okay.
And if anybody needs